Educational GMAT. Your partner in your GMAT journey.
So we do inequalities now. Inequalities does tend to get quite tricky and complex and is quite an important topic from a GMAT perspective. So there's a lot of theory also that we will do today, by the way, as part of inequalities. So number lines are perhaps the best way to visualize because left of 0 is negative, right of 0 is obviously positive. Now let's do it step by step. Let's look at mathematical operations, which would be addition, subtraction, division, and multiplication on inequalities. So what we're saying here is many operations such as addition, subtraction work exactly similar to the equalities. For example, this is given, right? Let's say it was an equality, x plus y is equal to 6. Then what would you do? This. Even when there is an inequality sign, you would do it exactly the same. There is no difference. So when it comes to addition and subtraction, there is no, there is, and the approach is no different from what it would be if it was an equality. All right. Now this is the most fundamental difference, and something you need to be very, very aware of, that when you multiply or divide an inequality by a negative number, the inequality sign flips. Now, why does it flip? It's not difficult to understand. Uh, for example, 4 is greater than 3, right? But then let's say I multiply this inequality by -1, negative. So this becomes -4, this becomes -3. Now notice -4 is lesser than -3. So that's the reason for this rule that we are learning, that whenever you divide or multiply an inequality by a negative number, the inequality sign flips. This is perhaps the most important, very basic fundamental rule that you need to always remember while solving inequalities. Another very minor thing is 4 is greater than 3, obviously can be rewritten as 3 is lesser than 4, right? So x is greater than y, for example, can be rewritten as y is lesser than x. Same thing. Okay. Now let's try solving this inequality. 5 minus 2x is lesser than 12. Now from here to here, what did I do? I subtracted 5 from both the sides. Since I'm subtracting and subtraction works exactly the same as with equalities, I don't need to worry about anything. I just subtract 5 from both the sides and retain the inequality sign, which in this case is lesser than. From here to here, what did I do? I multiplied both sides of the inequality by -1. Since I multiplied both sides of the inequality by -1, a negative number, what happens? Inequality sign flips. So lesser than becomes greater than. Okay. And finally, what did I do from here to here? I divided both sides of the inequality by +2. Since I'm dividing the inequality by a positive number, again, I don't need to worry about anything. The inequality sign remains the same. So for this inequality, the solution is x is greater than -7/2. On that note, guys, suppose it is given that x is greater than y. Can I conclude from this? So this is given. Can I conclude from this that nx is greater than ny? Can I conclude this? Can I
No, it will depend upon the sign of n.
Absolutely. So I cannot conclude this. The reason I cannot conclude this is because I do not know the sign of n. Because if n is negative, then the inequality sign would flip. Okay, so this is something that I cannot conclude. Can I conclude that n square x is greater than n square y? Yes. Why? Because I know for sure that irrespective of whether n is positive or negative, n square is always positive. Since n square is always positive, which means I can conclude this. Are we clear? Okay. All right. Solutions to multiple inequalities. Let's say these are the three inequalities presented to you, and you have to find a solution to this. What is the range of possible values of x? So these are the steps to solve it. First is solve each of the inequalities so that the inequality sign is in the same direction. X is greater than 7 is equivalent to saying 7 is lesser than x. X is lesser than 17, x is lesser than 14. Now you align the variables in the inequalities. 7 is lesser than x is lesser than 17, x is lesser than 14. And now what do? See, actually you can do it now using the number line also. 7 is lesser than x would be what? This direction. X is lesser than 17, this direction. X is lesser than 14, this direction. So now what do you find out? The common range that satisfies all the three inequalities. And what would be that common range? Between 7 and 14. So that's the final answer. That x would be between 7 and 14. Okay. All right. Now let's look at a few important rules of inequalities. Suppose these two inequalities are given to you. 5 is greater than 4, 3 is greater than 1. We can add them. We can add two inequalities. 8 is greater than 5. But we cannot subtract them. 5 minus 3, which is 2, and this is 4 minus 1, which is 3. So clearly 2 is not greater than 3. So we cannot subtract. Similarly, we cannot divide these two inequalities. 5 divided by 3 is obviously not greater than 4 divided by 1. Right? So to avoid complexity, there is just one rule that you have to remember. And what is the rule? Add inequalities that go in the same direction. Notice these were two inequalities, both of which were going in the same direction. So as long as there are two inequalities going in the same direction, you are allowed to add those two inequalities. Never subtract inequalities. Instead, multiply the one to be subtracted by -1 and add. For example, if it is given 1 is lesser than 3 and this is 5 is greater than 4. So what do? You multiply this inequality by -1. Since you are multiplying this inequality by a negative number, what happens? Inequality sign flips. So lesser than becomes greater than. Now notice you have two inequalities pointing in the same direction. Since you have two inequalities pointing in the same direction, what are you allowed to do? Add those inequalities, right? So there is only one rule to remember. Sum of two greater quantities is greater than the sum of two lesser quantities. What does it mean? A is greater than B, C is greater than D. Now, this is a greater quantity than this. This is a greater quantity than this. So sum of two greater quantities is always greater than the sum of two lesser quantities. So this is pretty much the only rule that you have to remember. So let's summarize our learning. You cannot multiply or divide an inequality by a variable unless you know the sign of the number that the variable stands for. And if you remember, we discussed that if it is given that A is greater than B, you cannot conclude that NA is greater than NB. Why can you not conclude? In other words, why can you not multiply this inequality by a variable? Because you don't know the sign. As we discussed on the last slide, you cannot subtract or divide two inequalities. You can only multiply inequalities if both sides of both inequalities are positive. And this is pretty much the only golden rule that you have to remember, that you can add inequalities pointing in the same direction. Now, as we discussed, inequalities plus absolute value is a combination that GMAT loves. So let's discuss that. Absolute value of x is lesser than 5. Now here, what does it mean by absolute value of x? It means absolute value of x minus 0. So here, what is the inflection point? 0. So basically this question is saying that distance of x from 0 on the number line has to be lesser than 5. All right. Now I have the number line already drawn here. Given that distance of x from 0 on the number line has to be lesser than 5, can x be this? No. Why not? Because then the distance of x from 0 will be greater than 5. So x cannot be this. Okay. Can x be this? Can x be this? Notice distance of x from 0 here is lesser than 5. Yes. So distance, right? This, what does absolute value indicate? Distance of x from 0. Correct? So if x is this, then distance of x from 0, do you agree, is lesser than 5 units? Lesser than 5 units? So possible. Can x be this? Absolutely. Can x be, let's say, this? Not possible. So in other words, given that distance between x and 0 has to be lesser than 5, so what has to be the value of x? Between minus 5 and 5, right? So minus 5 is lesser than x is lesser than 5 is the solution. All right. So this is what I call as a conceptual method. Let's also do it algebraically. Let's do it algebraically as well. Given that absolute value of x is lesser than 5, we discussed that the inflection point is 0. Since the inflection point is 0, algebraically, we always consider two cases. What are the two cases? One is x is greater than equal to the inflection point. Case 2 would be when x is lesser than the inflection point. Okay, x is greater than equal to 0. Give me a value of x. 5, or let's take 2. So for x is equal to 2, is this expression positive? Yes. Since this expression is positive, what do we do? Plus x is lesser than 5. Now let's take a value of x lesser than 0. Give me a value of x lesser than 0, minus 2. So for x is equal to minus 2, obviously this expression is negative. But since absolute value cannot be negative, what do? We add another negative sign to make it positive, right? Now, what do we do here? Multiply both sides of inequality by minus 1. Since we multiply both sides of inequality by minus 1, what will happen? Inequality sign will flip. So x is greater than minus 5. Agreed? Now notice x is greater than minus 5 and lesser than 5, which means what? That x is between what and what? Minus 5 and 5. So minus 5 is lesser than x is lesser than 5, which is the exact solution that we were getting conceptually as well. Right? So this particular question, you could have done it either conceptually through a number line or the algebraic method. Okay, now let's take another example. Again, since this is just the starting of the class, I'll do it both ways, conceptually as well as the algebraic method. Let's do it conceptually. Can you tell me what is the inflection point here? 4, right? It's always x minus something. Oops. So here the inflection point is 4. What does it mean inflection point is 4? Distance between what and what? X and 4 on the number line is lesser than 3. Okay, so 4, right? And let's take 5, 6, 7, 8, and so on. Here it would be 3, 2, 1, 0, and so on. Given that distance between x and 4 on the number line has to be lesser than 3, can x be this? Yes. Why, by the way? Because distance between x and 4 is obviously lesser than 3. So possible. Okay. Can x be this? Again, yes. Okay. Can x be this? No. Why not? Because then distance between x and 4 is actually greater than 3. Not possible. Can x be this? Yes. Again, why? Because distance between x and 4 is obviously lesser than 3 units. Can x be this? Yes, very nice. Again, why? Because distance between x and 4 is lesser than 3, right? It's 2 point something. Okay. Can x be this? No. Why not? Because in very nice. Because in that case, the distance between x and 4 is basically greater than 3. So now I am hoping that there is a pattern emerging. Given that distance between x and 4 has to be lesser than 3, what do you think is the permissible range of x on the number line? Between 1 and 7, absolutely. So the answer would be, for this, it would be 1 is lesser than x is lesser than 7. All right, now let's do it quickly using the algebraic method also. Since inflection point is 4, what do we do, guys? Consider two cases. One is when x is greater than equal to the inflection point. Case 2 would be when x is lesser than the inflection point. Greater than or equal to the 4, give me a value 5. So for x is equal to 5, tell me x minus 4, positive or negative? Positive. So we just put a positive sign here. All right. Now, when x is lesser than 4, give me a value. X lesser than 4, 3. All right. So for x is equal to 3, x minus 4, positive or negative? Negative. Since it's negative, but absolute value cannot be negative, for that reason, we put another negative sign here. X minus 4 is lesser than 3. All right. So here, obviously, x would be lesser than 7. Here, what do we do? Multiply both sides of inequality by -1. Since we are multiplying by a negative number, inequality sign flips, which means x is greater than 1. Now, notice x is greater than 1, lesser than 7, which clearly means that x is between 1 and 7, which is the exact answer that we were getting through the conceptual method using a number line as well. Is this very clear? Between 1 and 7. Okay. So the basic idea is, so actually we could do it conceptually. For example, absolute value of x is lesser than a. How should you interpret this? That distance between x and 0 on the number line has to be lesser than a. So again, if this is 0, this is a, this is minus a. Given that distance between x and 0 has to be lesser than a, can x be this? Sorry, Yes, right? Because then distance between x and 0 is obviously lesser than a. Similarly, can x be this? Again, yes. Can x be this? No. Can x be this? No. So which means given that absolute value of x is lesser than a, what is the permissible range for x? Very nice. Between minus a and a. So that's the solution. All right. Similarly, you could do it obviously algebraically as well. Similarly, how about this one? How do you interpret this? Absolute value of x is basically nothing but distance between x and 0 has to be greater than a. So again, since the inflection point is 0, so let's put 0 here. This is a, this is minus a. Given this, can x be this? If x is this, then distance between x and 0 is obviously lesser than a, but what does the question say? Greater than a. So which means not possible. Can x be this? Absolutely. Can x be this? No, because again, then the distance between x and 0 will be lesser than a, not possible. Can x be this? Absolutely. So again, given that distance between x and 0 has to be greater than a, what are the permissible ranges? Either x is in this direction or in this direction, which means either x is greater than a or x is lesser than minus a. Yeah. Okay, do remember the following. That absolute value of x plus y is lesser than equal to absolute value of x plus absolute value of y. Mind you, lesser than equal to. When will it be equal? When x and y have the same sign or when either x or y is equal to 0. Similarly, absolute value of x minus y will be greater than or equal to absolute value of x minus absolute value of y greater than equal to. When will it be equal? When x and y have the same sign and absolute value of x is greater than absolute value of y. I mean, after the class, you can actually try various values and just arrive at this expressions. Okay. Uh, Remember, if it is given that x square minus a square is greater than 0, then the solution to this is either x is greater than a or x is lesser than minus a. You can, I mean, we just quickly look at the derivation of this. X square minus a square is obviously can be factorized. How will you factorize this? X plus a into x minus a, right? So x plus a into x minus a is greater than 0. Now notice product of two expressions is positive. When will the product of two expressions be positive? Either when both are positive or both are negative, correct? So either when both are positive or both are negative. So we'll consider two cases. First is both are positive, which means x plus a is greater than 0 and x minus a is greater than 0. And what is the second case we'll consider? Both are negative. X plus a is lesser than 0 and x minus a is also lesser than 0. So here what do we get? X is greater than minus a and x is greater than a. Let's construct a number line 0, a, minus a. X is greater than minus a, this area. X is greater than a, this area. So what is the common area? Sorry, common, correct? So common would be x is greater than a. That's the common area, correct? Okay, now let's look at this. X is lesser than minus a and x is lesser than a. Again, construct a number line. This is a, this is minus a. X is lesser than minus a, this area. X is lesser than a, this area. What's common here? X is lesser than minus a, right? So what are the solutions then? Either x is greater than a or x is lesser than minus a, which is the exact solution that we are getting. All right. Now, given this kind of an inequality, obviously one way would be for you to factorize. But then since this kind of a pattern is so common, so you would be better off just remembering the solution. So this is when x square minus a square is greater than 0. Now we do when x square minus a square is lesser than 0. Again, the approach would remain the same. Let's factorize it. X plus a into x minus a is lesser than 0. Now notice product of two expressions is negative. When will the product of two expressions be negative? When one is positive, the other is negative, correct? So we'll consider two cases. First is positive, second is negative, or first is negative, second is positive. Case one would be x plus a is positive and x minus a is negative. Case two will be when x plus a is negative and x minus a is positive. So here what do we get, friends? X is greater than minus a and x is lesser than a. Now again, let's draw a number line. This is 0, this is a, this is minus a. X is greater than minus a would be this area. X is lesser than a would be this area. So what's the common area? This one, right? So minus a is lesser than x is lesser than a. All right, now let's consider this. X is lesser than minus a and x is greater than a. So again, let's construct a number line. 0, a minus a. X is lesser than minus a, this area. X is greater than a, this area. Do we have any common solution? No. So in this case, we have no solution because there is no common area. So the final answer is just this. Minus a is lesser than x is lesser than a, which is the exact answer that we are getting here. Okay. Now this is quite important and very extensively tested on GMAT. If y is equal to root of x square, then the solution to this is y is equal to absolute value of x. In other words, what we are saying is, guys, that root of x square is not equal to x. Root of x square is equal to absolute value of x. Please remember this. Let's take an example, by the way. Let's take an example. Suppose that, let's take this as x, x square. Let's take a root of x square and let's take absolute value of x. Okay. Suppose we take x is equal to 2. What is x square? 4. What is root of x square? 2. What is absolute value of x? 2. All right. So in this particular case, root of x square is equal to x. Agreed in this case. Okay. On the other hand, let's take minus 3. X is minus 3. What is x square? 9. Root of x square? 3. And what is absolute value of x? Notice x is minus 3. So what is the absolute value of x? 3. Now notice in this particular case, root of x square is not equal to x. And that's exactly what we are saying here. Root of x square is not equal to x. Root of x square is always equal to absolute value of x. Notice root of x square is equal to absolute value of x. Root of x square is equal to absolute value of x, always. So this basically means that y cannot be negative, but x can be. So remember the following: root of x square is equal to x if x is positive. On the other hand, root of x square is equal to minus x if x is negative. Okay. So if it is given that absolute value of x is lesser than 1 by x, let's say this is given, then the solution to this is that x is between 0 and 1. Now you can obviously solve it algebraically, but let's actually quickly substitute values. Suppose x is equal to, let's take minus 1. Let's take minus 1. If x is equal to minus 1, what is left hand side? If x is equal to minus 1, then left hand side will be 1 because it's absolute value of minus 1, right? And on the other hand, what is right hand side? 1 by minus 1, which is minus 1. Clearly, 1 is not lesser than minus 1, right? So uh, obviously negative values do not hold true. Similarly, let's take x is equal to, let's say 2. What will be the left hand side? 2. What will be the right hand side? 1 by 2. Again, notice 2 is not lesser than 1 by 2. Correct? On the other hand, let's take x is equal to half. If we take x is equal to half, what's left hand side? 1 by 2. What's right hand side? 2. So notice 1 by 2 is lesser than 2. So if you look at it this way, only values of x between 0 and 1 will satisfy this condition. Okay. So I've just substituted values here. In reality, what can you do algebraically? Algebraically, what do you do? Notice this is basically inflection point is what? 0. So what would you do? Consider two cases. Case 1, x is greater than equal to the inflection point. Case 2, x is lesser than the inflection point. Greater than equal to inflection point, what do you get? X is lesser than 1 by x. Lesser than inflection point, what do you get? Minus x is lesser than 1 by x. Solve this, and then this is the final answer that you would arrive. Correct? Similarly, now this should be easy. Given this, the solution is this. How do you arrive at the solution? We just discussed it. If x square is lesser than a square, then what was the solution? Minus a is lesser than x is lesser than a. This is exactly what's happening here. If x square is lesser than 1, x square is lesser than 1 is equivalent to saying obviously x square is lesser than 1 square. So what will be the solution? Minus 1 is lesser than x is lesser than 1. Correct? Okay, now if it is given that x is greater than x square, then the solution to this is again x is between 0 and 1. So since this pattern is so common, you would be better off memorizing this. Otherwise, you can obviously do it algebraically as well. X is greater than x square means what? X minus x square is greater than 0. X into 1 minus x is greater than 0. Now what do we have, guys? Product of two expressions is positive. When will the product of two expressions be positive? Either when both are positive or both are negative. So we consider two cases. X is greater than 0 and 1 minus x is greater than 0. Solve it. Case 2 would be x is lesser than 0 and 1 minus x is lesser than 0. Solve it. So again, once you solve, you will ultimately arrive at this answer. All right. Okay. Handy things to remember. If both sides of inequality are positive, you can safely perform square or square root of both the sides of inequality. For example, if it is given that a and b are positive and a is lesser than b, we can safely say a square is lesser than b square. We can also say square root of a is lesser than square root of b. Why are we able to say that? Because if both sides of inequality are positive, which is the case here, then we can safely perform square or square root of both sides of the inequality. Right? Similarly, if it is given that root x is greater than root y, since square root can never be negative, which means we know both sides are positive. Since both sides are positive, we can square both the sides and arrive at x is greater than y. Okay, so This is a continuation of what we discussed on the last slide, that we can raise both parts of an inequality to an even power. Even power means what? Square, fourth power, and so on. If we know both sides of inequality are non-negative. So yeah, for example, we know that both sides of inequality are non-negative. Since we know both sides are non-negative, we can square both the sides. Now, this is very important application of this concept. Suppose it is given that absolute value of x minus y is greater than absolute value of x plus y. We obviously know by now that absolute value cannot be negative, right? Which means now both sides of this inequality are non-negative numbers. Since both sides of inequality are non-negative, what can we do? Square both the sides, right? So that will enable us to remove the absolute value sign. So square both the sides. So x square plus y square minus 2xy is greater than x square plus y square plus 2xy. X square, y square get cancelled. So minus 4xy is greater than 0. What do we do from here to here? Multiply both sides of inequality by minus 4. Since we are multiplying both sides inequality by minus 4, what happens? Inequality sign flips. So xy is lesser than 0 is the solution of this inequality. This is quite a handy concept. Again, in any inequality question, if both sides of the inequality are absolute values, then the first thing you should look at is the possibility of squaring both the sides. Okay, on the other hand, we can always raise both parts of an inequality to an odd power. Odd power, mind you, for example, power of 3. Same for taking an odd root of both sides of inequality. For example, minus 2 is lesser than minus 1. So minus 2 whole cube will be lesser than minus 1 whole cube. So guys, I'm just summarizing what we've discussed on this slide. You can raise both sides of an inequality to an even power. For example, squaring. You can raise both sides of an inequality to an even power only when you know that both sides of inequality are non-negative. All right. On the other hand, you can always raise both sides of an inequality to an odd power. Completely unmindful of whether both sides are positive, both sides are negative, one is positive, one is negative, whatever. You can always raise both parts of an inequality to an odd power, but you can raise both parts of inequality to an even power only when you know that both sides of inequality are non-negative. That's the summary. Okay, absolute value of x, y will be, by the way, equal to absolute value of x into absolute value of y. Similarly, absolute value of x by y will be equal to absolute value of x divided by absolute value of y. Inequalities with multiple factors. For example, this is an inequality that is given to you. X minus a into x minus b into x minus c is lesser than 0. And let's say we are supposed to solve it. Now, I'll tell you the classical way to solve it. The classical way would be product of three expressions is negative. When will the product of three expressions be negative? Either when will it be negative? One is negative, other two are positive. This is positive, this is negative, this is positive. This is positive, this is positive, this is negative, or all the three are negative. Correct? So how many cases do we have to consider? Four cases. Case one would be what? X minus a is negative and x minus b is positive and x minus c is positive. Solve it. Case 2 would be what? This one. X minus a is positive and x minus b is negative and x minus c is positive. Solve it. Case 3 would be this. X minus a is positive and x minus b is positive and x minus c is negative. Solve it. Case 4, x minus a is negative and x minus b is negative and x minus c is again negative. Solve it and then combine. Notice this is obviously extremely tedious, right? So what we are looking at now, very important, that's called the wavy line approach. Wavy line approach. So here, for example, by what we've discussed so far, what are the inflection points? The inflection points obviously here would be A, B, and C, right? So what we do is we essentially plot the inflection points on a number line. Now, when we plot these inflection points on the number line, in how many areas is the number line divided? 1, 2, 3, and 4, right? And then we consider the values of x in each of these areas. Let's do it through an example. Let's do it through an example. And this is the example that I'm considering. X into x minus 3 is lesser than 0. Let's say we have to find out a solution of x for this. So again, what are the inflection points here? 0 and 3. So we plot inflection points on the number line. In how many areas is the number line now divided? 3 areas, right? This is one area, this is second, and this is third. Now what I do is consider a value of x in each of these areas. Let's first consider a value of x in area 1. Give me a value of x in this area. -1, right? If x is equal to -1, then what is the value of this expression? Value means positive or negative. Notice this would be what? If x is equal to -1, then notice this is obviously -1, and this would be how much? -1, -3. So which means this expression, tell me positive or negative? Positive. -1 into -4, positive, correct? So then what I do is I say that the expression is positive. What am I saying? For any value of x in area 1, the value of this expression is positive. Okay. Now let's take a value of x in area 2. Give me a value of x in area 2. 2. Let's take 2. So for x is equal to 2, this is 2 and this is 2 minus 3. So which means the value of this expression positive or negative? Negative. Very nice. So we put negative here. And finally, let's take value of x in area 3. Give me a value of x in area 3. 4. Very nice. For x is equal to 4, notice 4 into 4 minus 3, which is positive. Agreed? So if you look at it, the summary is that for values of x in area 1, the value of this expression is positive. For value of x in area 2, the value of this expression is negative. For values of x in area 3, the value of this expression is positive. But according to the question, what is the requirement? The value of this expression, should it be positive or negative? Negative. And when is the value of this expression negative? Only when x is in area 2. So that's the answer. That's the answer. That for any value of x between 0 and 3, the value of this expression is negative. So the value of x between 0 and 3 is the answer. Are we clear? Much shorter way. That's called the wavy line approach, by the way, because if you plot it, it's kind of a wavy line. Okay. Now this would sound very difficult to you. Let's say we have to solve this. X minus a raised to the power of 6 into x minus b into x minus c into x minus d is greater than 0. The thing that we are saying is, notice this is an even power, right? And any variable raised to an even power will always be positive, correct? So you can basically just treat this as a positive constant, In other words, the solution of this inequality will be the same as the solution of x minus b into x minus c into x minus d is greater than 0. So just ignore this, considering this as a positive constant. And how do we find out the solution to this? We just discussed on the last slide. How do we find it? Using the wavy line approach by obviously plotting the inflection points and then dividing it into various areas and then considering the value of expression in each of these areas. So that's the way to solve it. Suppose that we have odd power here. Notice x minus a raised to the power of 5. The thing what we are saying is, even when it is x minus a, this is equivalent to x minus a raised to the power of 1. Correct? So x minus a is anyway raised to an odd power. In other words, the solution of this inequality will be the same as the solution of x minus a into x minus b into x minus c into x minus d is greater than 0. So instead of power 5, you can just reduce it to power of 1, because 1 is odd, 5 is also odd. Again, how do you solve it? Using the wavy line approach by plotting A, B, C, and D on the number line as inflection points. Clear? All right. So we are almost ready, almost done with theory. This is one question that I wanted to deal with because this is so very prominent in inequalities. Can you guys tell me what's the answer?
So C. Oh, sorry. D.
Very nice, very nice. Now the thing is, uh, given that x is between -1 and 3, can you tell me what are the what can be a possible value of x? In fact, again, it can be decimals also, right? So it can be minus 0.99, agreed? Or minus 0.75, for example, minus 0.5. Obviously, it can be 0, 0.001, 0.5, 0.999, whatever. I'm just writing some values here, 1.999 or 2.87 and so on, correct? Given this, the question is asking which of the following must be true. Tell me, why is alpha not correct? No, no, that's not the correct way to look at it. Why can we not say that x must be greater than 0? No, because x can be lesser than 0 as well. So we can't say x must be greater than 0. Similarly, why can we not say that x is lesser than 0? Because x can be greater than 0 as well. Why can we not say that x is greater than 1? Well, because x can be lesser than 1 as well. All right, why can we not say that x is greater than 10? Well, because x is never greater than 10, right? All the values of x permissible within this range have to be lesser than 10. On the other hand, now why is David correct? Because all permissible values of x in this range must be greater than minus 10. So, in fact, while David is correct, other answers that would also have been correct here, for example, would have been x is lesser than 10, absolutely must be true. X is lesser than 1000, absolutely must be true. X is greater than minus 28, absolutely must be true. Why? Because all the permissible values of x within this range must satisfy all of these ranges. Are we clear? There are a lot of must be true, this kind of examples in our assignments as well, because this is quite a prominently tested concept on GMAT. Okay, now let's start doing questions, guys. All right. Very, very nice. Very nice, Anand. So let's look at it. Let's first consider this. 1 is greater than 1 minus AB. Now, what can I do? Subtract 1 from both the sides. Again, addition or subtraction, I don't need to worry. So 0 is greater than minus AB, which means minus AB is lesser than 0. Now, what do I do? Multiply both sides by minus 1. Since I'm multiplying both sides by a negative number, what happens? Inequality sign flips. So AB is greater than 0. Now, notice I obviously keep all of these in mind. And then what I can do is I can divide both sides of inequality by b square. Can someone tell me why am I able to divide both sides of inequality by b square? Very nice, Nathan, because I know that it doesn't matter whether b is positive or negative, b square will always be positive. Since I know b square is always positive, I can safely divide both sides or multiply both sides by a positive number, correct? So then what do I get? A by b is greater than 0. So this is absolutely correct. Okay, now let's take this part of the inequality. 1 minus AB is greater than 0, which means minus AB is greater than minus 1. Now what do I do? Multiply both sides of inequality by minus 1. Since I'm multiplying by a negative number, what happens? Inequality sign flips, and that's exactly what this is. There is no way I can conclude second. So as Anand very rightly pointed out, first and third statements are correct. Are we clear? Sakshi, tell me, where are you stuck? Can you repeat? Divide what by b square? Oh, in this one. Okay, let's try that. Let's try that. Uh, so yeah. So so you want this to be divided by b square. That Yeah, but that would not give us anything actually, Sakshi, unfortunately. AB by b square is lesser than 1 by b square. This is fine. Yeah. So notice we cancel this. So it just says a by b is lesser than 1 by b square, but that doesn't lead us anywhere. Okay, data sufficiency question for you guys. All right, that was quick. Uh, let's just give a couple of more minutes. Is mn lesser than 12, given that m is lesser than 2 and n is lesser than 6? So obviously statement 1 alone is insufficient because we have no idea about value of n. Statement 2 alone is insufficient because we have no idea about the value of m. Now next, what do? Combine both of them. So even when we combine both of them, now notice when we combine both of them, what does it mean? M is lesser than 2 and N is lesser than 6. So even after we combine both of them, notice M can be 1 and N can be 1, in which case Mn is lesser than 12. On the other hand, M can be minus 3, for example, N can be minus 10, in which case Mn is not lesser than 12. So after combining both the statements also, we are getting two conflicting answers whether Mn is lesser than 12. So which means we just do not have sufficient data. So Edward is the right answer. Very nice, Anand. Okay. All right. Okay. Now, how do we do this? Maximum value of xy. So let's first solve these individual inequalities. 2y plus 3 is lesser than equal to 11. So 2y is lesser than equal to 8. Now what am I doing? Dividing both sides of inequality by 2. Why can I do that? Because 2 is positive. So I know that the inequality sign will not change. So y is lesser than equal to 4. Sorry. 4, and on the other hand I also know that x is between 1 and 5. So we have to find out the maximum value of xy. When will the value of xy be maximum? Very nice. When x is how much? 5 and y would be 4, right? So that would be 20. That's the final answer. Easy one. Okay. How much? I don't remember the answer. Now we have to find out the maximum. All right. Maximum value of m minus n. When will the value of m minus n be maximum? When? Very nice. M is maximum and n is minimum. Agreed? Now I think this is easy. What's the maximum value of m? 7. What's the minimum value of n? Now that's important. Theoretically, n can be, it's not given that n is an integer. It's not given, right? But the point is, we have to find out the integer value, right? So there's no point in taking a decimal value of n. So that now would be m minus n, which would is 9. So maximum integer value of m minus n is 9. Okay. I'll give you guys good 5 minutes for this. Not easy. Not easy. Okay, let's wait for others. Okay, now let's do this. So I can obviously take 2 outside. So what am I left with? X minus 3 by 2, right? Basically. 3 by 2 is equal to x minus 5, which means 2 times x minus 1.5 is equal to x minus 5. Now, what's the inflection point? 1.5. So again, what do we do? Consider two cases. X is greater than equal to the inflection point, or X is lesser than the inflection point. So greater than 1.5, give me a value 2. So for X is equal to 2, clearly this is positive. So we put a plus sign here, correct? Plus 2 times X minus 1.5 is equal to X minus 5. Okay, now let's take a value lesser than in 1.5. Give me a value 1. Okay, so for x is equal to 1, x minus 1.5, positive or negative? Negative. But since absolute value cannot be negative, what do? We put a negative sign. Minus 2 x minus 1.5 is equal to x minus 5. Clear so far? Very standard approach. So from this, what do we get, friends? 2x minus 3 is equal to x minus 5. So 2x minus x is equal to how much? X is equal to minus 2. Agreed? Now, however, what was the condition that we started with? Greater than 1.5. Is minus 2 greater than 1.5? Obviously no. So this is not a valid solution. Okay, now let's come to this. Minus 2x plus 3 is equal to x minus 5. So minus 3x is equal to minus 8, which means x is equal to 8 by 3, which is 2 point something. Agreed? But what was the condition that we started with? Lesser than 1.5. Is 8 by 3 lesser than 1.5? No. So which means how many solutions does this have? No solution. Are we clear? As we always discussed, that whenever you get a solution, make sure that it satisfies the condition. So 0 solutions. But it will be positive or negative based upon the inflection value, right? That's the reason, that's the whole concept of inflection point. Yes, but you missed the condition then. That, please always take the inflection point into consideration before proceeding with the algebraic equation. Because this is a very important step, that the final solution that you are getting, is it conforming with the condition that you had assumed? Okay. This is again quite a tough question. It's a very classical GMAT inequalities question. So I'll give you guys 5 minutes for this. If n denotes a number to the left of 0 on the number line, such that square of n is less than 1 by 100, what's the reciprocal of n? By the way, it's a GMAT official question. It actually uses a lot of concepts that we've discussed so far in the class.
So minus 10?
And you are there. But what do you, so are you saying n is equal to minus 10
No,
or is there a range? Sorry?
the reciprocal of n, no?
Yes. Is its value minus n or is there a range associated with it?
The value should be minus 10 according to
Okay.
the value of reciprocal.
Yes, I understand that. Any progress? So first of all, tell me, is n positive or negative? Negative,
Negative.
because it says to the left of zero, right? So which is clearly negative. So that was one concept that we discussed. So it'll utilize a lot of concepts. Now it says that what's the inequality that I should form, by the way?
N square less than 1 by 100.
Very nice. Correct. So how do you solve this, by the way? How do you solve it? Right? Does it remind you of something? Does it remind you of something? Remember, we discussed x square minus a square is lesser than 0. And what was the solution of this? Minus a is lesser than x is lesser than a. Do you remember that? Right? Similarly, this would be what? N square minus 1 by 10 whole square is lesser than 0. So what will be the solution of this?
So minus 1 by 10 less than x less than 1 by 10.
Very nice. Now, one thing that we've been given, however, is that n is negative, right? Since n is negative, which means what? That n has to be between what and what?
Oh my god,
Minus 1 by 10 and 0. Agreed? Because we've been given an additional constraint that n is negative, right? So basically, what we are saying is minus 1 by 10 is lesser than n. And obviously, n is lesser than 0. Correct? We have to find out the value of 1 by n. Given this, how do we find out the value of 1 by n? That's the question I have. Given this, how do we find out the value of 1 by n? Now, from this, notice minus 1 by 10 is lesser than n, which means n is obviously greater than minus 1 by 10. Correct? What I can do now is what can I do? How do I proceed from here? I have to find out, mind you, the value of 1 by n. How do I find out the value of 1 by n given this? First multiply the by -1. Okay, what am I getting with that? From this, how do I find out the value of 1 by n? Can I divide both sides by can I divide both sides by n? I obviously can, but when I'm dividing both sides by n, what will happen? Inequality sign will flip. Why will the inequality sign flip? Because n is negative, right? So when I divide both sides by n, what happens? N by n is lesser than -1 by 10n. Agreed? So 1 is lesser than -1 by 10n. Correct? Now what can I do? Multiply both sides by 10. And since it's a positive number, inequality sign will not flip, right? So 10 is lesser than -1 by n, right? Which means -1 by n is greater than 10, correct? And now what do I do finally? Multiply both sides by -1. And again, since I'm multiplying both sides by -1, what will happen? Inequality sign will flip again, correct? So 1 by n is lesser than -10. That's the answer, right? Which is what we had to find out. What's the value of 1 by n? The answer is it is lesser than -10. So Yashid, you did arrive at -10, and that's the reason I said, is -10 the actual value, or is there a range associated with it? The answer is there is a range. And what's the range? That the reciprocal of n will be lesser than -10.
Yes, got it.
All right. Not easy. Not easy.
So does inequality as a topic come in the early range of scores, or is it like once you start
Oh
getting
no.
questions right consistently, it shows up as a
Oh,
difficult?
inequality. So there is no. So Yashi is asking whether if she gets an inequality question in the actual exam, does it mean that she is still at a moderate or an easy level, or is it at an advanced level? Could be either way. Could be either way. You can, in fact, this very question I would say would be definitely more than moderate level difficulty on GMAT. On the other hand, till now, the questions that we did in equality were relatively very easy. So they can be across difficulty levels, honestly.
Got it.
Yeah. Okay. Oh, let's do this as the last question for the day, guys. Eh, Data sufficiency.
So the answer should be B.
All right. Okay. Now, see what will happen is in data sufficiency, many a times a way to solve the answer would be to simplify the question statement itself. What's the question statement? Is n square lesser than n cube, right? So what we can do is try to simplify this. So one thing that we can obviously do is divide both sides by n square. Why am I able to divide both sides by n square? Because we know n square will always be positive irrespective of whether n is positive or negative, right? So then what are we left with? Is 1, right? This gets cancelled obviously. Is 1 lesser than n? In other words, is n greater than 1? Notice this looks so much simpler and more manageable than this, right? So we just have to find out, is n greater than 1 based upon these two statements. Agreed? So let's take statement 1. What does statement 1 say? N square is lesser than 1. This should hopefully remind you what form are we talking about. N square minus 1 is lesser than 0, which is n square minus 1 square is lesser than 0. Do you guys remember the solution to this? Minus 1 is lesser than n is lesser than 1. That's the solution. Correct? Question was what? What do you think? Is statement 1 sufficient? What do you guys think? Is statement 1 sufficient? Absolutely. Is n greater than 1? From statement 1, we have been able to conclusively say that n is not greater than 1, right? Because notice it has to be between minus 1 and 1, so which means it's not greater than 1. Since we've been able to find a conclusive answer from statement 1 alone, which means statement 1 alone is sufficient. Friends, are we clear? Right, so now I think this should be easy, right? So is n greater than 1? That's the question we need to answer. So from statement 1, it's sufficient. Similarly, how about statement 2? N cube is lesser than 1. So for this to be true, it has to be the case that n is lesser than 1. Otherwise, n cube cannot be lesser than 1. See, just think about it. Any value of n greater than 1, let's say 1.1, right? So if n is 1.1, then n cube, which is basically 1.1 whole cube, will obviously be greater than 1. But if n cube is given to us as lesser than 1, which means n has to be lesser than 1. So which means statement 2 alone is also sufficient. And so the answer is actually David. So statement 1 alone is sufficient and statement 2 alone is also sufficient. Are we clear, guys? All right. So on that note, let's come to end of the class. So I'll upload this PPT. There's a lot of theory in this class, guys. A lot of theory as you would have experienced. So my request would be to watch. This theory is important. So watch the video again, reinforce the theory, and only then start working on the assignments. We have very prolific assignments in inequalities, all questions in increasing order of difficulty, elaborate explanations. Any doubts that you have, please feel free to get back to me. All right. That's all. Thanks. Bye.